Hello viewers, I am Kausalya. Today we are going to solve problems in exercise 10.2. Here the first problem is, from a point Q, the length of the tangent to the circle is 24 centimeter and the distance of Q from the center is 25 centimeter. The radius of the circle is. So here you see there is a point Q, right? So there is a point Q and the length of the tangent to the circle is 24 centimeters, right? So here this is your tangent and the total length is 24 centimeter. Then the distance of Q from the center, okay, this is your point Q. So the distance of Q from this center, right, what it is? It is 25 centimeter. Then the radius of the circle, we have to find the radius, right? So this is our circle with center O and QP is the tangent. Its value is 24 centimeter and here the distance from point Q to the center is 25, right? So we have to find the radius. So the first thing is, as we already know, right, the angle between the radius and the tangent to the circle is, it is always 90 degrees, right? So this is a right angle triangle. Now here we have to use our Pythagoras theorem. So what is Pythagoras theorem? That is hypotenuse square is equal to square, that is sum of the square of remaining two sides, right? So here which side is the hypotenuse? The side which is opposite to this 90 degree is the hypotenuse, right? So here OQ is the hypotenuse. Therefore, here we can write, you see, OQ square is equal to QP square plus OP square or PO square, right? So now we need only OP, right? So just rewrite the expression. So OP square is, I am moving this QP square to the left hand side. So OQ square minus QP square. So the value of OQ is 25 and QP is 24, right? So just find the square and substitute the values here. And the value of, you see, OP square is, it is 49 here, right? So OP is square root of 49, which is equal to 7 centimeter. So here you see, when you look at this diagram, this OP is nothing but this is your radius of the circle and its value is equal to 7 centimeter, right? So problem number 2. In the figure, if TP and TQ are the two tangents to the circle with center O, so that angle POQ is equal to 110 degrees, then angle PTQ is equal to. So here the thing is, you see, we are having TP and TQ. These two are tangents to a circle, right? So this is the point T and TP and TQ are the tangents to the circle, right? And the circle with its center, okay, the center point of the circle is O, so that, right, POQ is equal to 110 degrees. So this angle POQ is 110 and we have to find the value of PTQ. What it means? You have to find the value of T here, right? You have to calculate this angle, right? So you see, again by, that is the angle between a tangent and the radius is always equal to 90 degrees, right? So here we are having 90 degree. Similarly, this is the radius, right? This is also radius of the circle and this is a tangent. And this angle is also 90 degrees, right? Then we are, you see here we are having a quadrilateral, right? That is a four-sided figure is a quadrilateral. So here we are having a quadrilateral. So sum of all the angles of the quadrilateral is equal to 360 degrees, right? So you see, in a quadrilateral, the sum of the angles is 360 degree. So what does it mean? That is, how many angles do we have? 1, 2, 3 and 4. So when you add all these 4 angles, then the value is equal to 360, right? So just write down the values initially. You see it is angle P plus angle O angle P, angle O, angle Q and angle T, right? What is the value of angle P? It is 90. What is the value of angle Q? Again it is 90. And the value of angle O is given in the problem, it is 110, right? So just substitute the values here. So you see, once you substitute it, here it is equal to 360. So here when you add these three angles, it is equal to 290 degrees. We have to find the value of angle T. So now I am moving this 290 to the right hand side. So this plus 290 becomes minus. So 360 minus 290 gives the value of angle as 70 degrees, right? So the angle T is 70. So here it is asked as angle PTQ, right? So write it as angle PTQ is equal to 70 degrees, right? So the third problem is, if tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degrees, then angle POA is equal to. So here you see, there is a circle with center O, right? So just draw a circle with the center O. And we are having two tangents, right? One is PA and another one is PB. So P is the point outside, right? And PA and PB are the tangents. And here you see the tangents are inclined to each other at an angle of 80 degrees, right? So here the angle between the tangents are 80 degree. We have to find the angle POA, right? POA. So here we need to find this angle, right? So as usual, you see, so we are considering this as two triangles, right? One as OAP and another one as OBP, right? So in this case, you see this OA is equal to OB. Why? Because they are the radius of the circle. Then the next thing is PA is equal to PB. Why? Again, this is according to our theorem. The lengths of the tangent drawn from an external point to a circle are equal, right? So here PA is one tangent and PB is one tangent, and these two tangents are drawn from this point P, right? Therefore PA is equal to PB. And what about this side? You see, we had compared this length and this length, and we have compared this and this, and the left out thing is this OP. You see, this OP is common for this triangle as well as for this triangle, right? So just make a note of it. OP is common. So here all the three sides, okay, three sides of one triangle is equal to the three sides of other triangle. So triangle OAP is similar to triangle OBP, right? So why? Because by triple S congruence criteria, because all the three sides, okay, get matched with, all the three sides of one triangle get matched with the three sides of some other triangle. So these two triangles are similar, right? Now here the thing is, you see, angle OPA is equal to OPB because this is due to CPCT. So that is corresponding parts of congruent triangles. So again we will look back. You see, angle OPA, that is this angle, right, is equal to angle OPB. Again OPB. Okay, OPA is equal to OPB. The reason is, since these two triangles are similar, by using this CPCT criteria, we can tell that this angle is equal to this angle, right? Now, you see, this OPA is equal to OPB, right? But this value is equal to half of APB. Again, we have to look back at this diagram, right? Now we have proved that this angle is equal to this angle. Then this angle is nothing but, that is OPA or OPB, right? Both are equal to half of the main angle. What is this bigger angle? Half of this angle is APB. Can you get? That is this angle APO is equal to angle BPO, right? So this angle is equal to this angle, which is equal to half of this angle, right? So what is the value of APB? It is 80 degrees. So half of 80 degree is nothing but it is 40 degree, right? So now we have calculated the value. Next we are going to consider in triangle OPA, right? Because we need to find this angle. So now we are considering the triangle OPA, right? You know this angle is 90 degree and this angle is 40 degree. Just now we have calculated, right? So it is easy to find this angle, right? So in triangle OPA, the summation of angles, angle O plus angle A plus angle P is equal to 180 degrees, right? So OAP, angle A is 90, right? And angle P is 40 here. We need to find this POA. So keep it as such. So which is equal to 180. So 90 plus 40 is 130, right? Therefore the angle POA is 180 minus 130, which is equal to 50 degrees, right? Our fourth problem is prove that the tangents drawn at the ends of the diameter of a circle are parallel. So here we are having a circle, right? And tangents drawn at the ends of the diameter of the circle. So this is the circle and this is the diameter, right? So even you can draw like this also. This is the circle and this is your diameter, right? Both holds the same meaning. And the tangents drawn at the ends of the diameter. So what is the diameter end? This is one end of the diameter and this is other end of the diameter. So at this point we are drawing tangents, right? And finally we have to prove that these two tangents are parallel, right? So here if you draw diameter like this, then you can draw tangents like this, okay? Both these diagrams are same. Now we will consider this diagram, right? So here in this AB and CD are the tangents, right? So AB is a tangent at point P and CD is a tangent at point Q, right? Now we are going to find the angles. So here you see what is the value of angle OPA? Can you tell? OPA, that is what is the value of this angle P. So by theorem 10.1, right, the radius and the tangent are perpendicular. So here the angle will be 90 degrees, right? Now okay, just write these things, okay? OPA is equal to 90 degree by tangent radius theorem. Similarly, now consider this tangent CD, right? So what is the value of OQD? What will be the angle here? Again, this is your radius and this is your tangent. So automatically here the angle will be 90 degrees, right? So again, this also by this tangent radius theorem, right? So you see, when you compare these two things, that is 1 and 2, the right hand side is 90 degree, right? So automatically this will be equal to your left hand side. So here this is equal to, that is OPA is equal to OQD, right? So OPA is equal to OQD. These angles form a pair of equal and alternate interior angles. That is, this is just reverse of the interior angles, right? Wait, let me explain. You see, here you will be having two parallel lines, right? And there will be a line like this, right? So here in this case, what we will say, for example, let angle at this point be A, right? So automatically this angle will be equal to A because they are said to be interior angles, right? That is, interior angles means that in the form of Z, you see, right? In the form of Z, this angle will be equal to this angle, right? Like this. So when these alternate angles are equal, right, then these two lines are said to be parallel. Right. So here what we have done, there are two parallel lines and there is another line which cuts those two lines. So this these alternate angles are equal. But here what we are trying to prove, here we are proving in reverse. Since the angles are equal, therefore these two lines are parallel. Right, that's the condition we are proving here. But the diagram looks little bit different, that's it. You see, I'll explain with this diagram. So here, that is between these two lines, we are drawing a line in the form of just a slanting part, okay, just like in the form of Z. So instead of this slanting line, if you have a straight line, then this diagram will depict this, right? Just like this. So this angle is equal to this angle. This is what we proved, right? Therefore, these two tangents AB and CD are parallel. Can you get? And finally, we can prove, since these alternate angles are equal, the tangents AB and CD are parallel. Right. So that's all. If you have any doubt, let me know in the comment section. Thank you.